Okay, we have an interesting integral from the MIT Integration Bee 2023 Quarterfinals Round 2 Problem 2. We have the integral of 1 minus 2x over 1 plus x all squared, x 2/3 dx. Okay, now to get started with it, the first thing I want to notice is just the similarity to the quotient rule, where we've got something squared here and we're subtracting in the numerator. Our formula for the quotient rule, if we have something like f over g, if we take the derivative of this, the formula is going to be f prime g minus f g prime over g squared. And so really the only difference in what we have here and what we have here is just this x to the 2/3. Well, why don't I just multiply that into the numerator to get it to look more like this? So when I do that and rewrite the integral, it's going to become x 2/3 minus, dividing in here, we're going to get minus 2x to the 1/3. And sorry, this should be minus 2/3 over here. And doing it that way, we're kind of all lined up here. And for this to work, we're going to want this right here to be our g value. So what that's going to allow us to do, if we assume g to be 1 plus x, in order to get this g prime value, let's just take a derivative. Derivative of this is just 1. And then from here, this part can be a little tricky because we want to line up. We're saying we want this numerator here to be the same as this stuff right here. It would be nice if we could kind of match them 1 to 1. Like what we want is a little equation, like let's say fg prime, this part, we want to equal this part. So we want fg prime to be 2x 1/3. But we already know that g prime is 1, or we're assuming that if this is correct, this is 1. So what we need is f equal to 2x 1/3. But that's going to allow me to take a derivative to find the f prime value we need over here. So for f prime, this is going to be 2/3 x. With power rule, this becomes minus 2/3. So now we already set it up where our fg prime, that part's going to match. The g squared matches, of course. What about this f prime g? So f prime g, we want it to match this. But plugging in, it's going to be 2/3 x minus 2/3, and g is going to be 1 plus x. Distribute this all out, and what we have is 2/3 x minus 2/3. And then on this part, we're going to have plus 2/3 x 1/3. Well, what we have right here, this definitely does not match this. And so at this point, we could be kind of stuck, but let's see what happens if we put them all together. If we get the full numerator, f prime g minus fg prime, we have the values we need, so we can just kind of subtract and see what's going on. So for f prime g minus fg prime, it's going to be this minus this, so we have 2/3 x minus 2/3 plus 2/3 x 1/3, then minus this piece, 2x 1/3. But then we combine this part here and this part here. And so what we're left with, this is going to become minus 4/3. Yeah, minus 4/3 x 1/3. Well, comparing this to what we have in the numerator, it definitely doesn't match. But what you'll notice is we're actually just off by a constant. We have the right pieces, x minus 2/3, x 1/3. We can actually fix this, like to get this to be the same thing as x minus 2/3. All I need to do is multiply in by 3/2, do it on both sides. So if we do that, this is going to cancel out this right here, and we get x minus 2/3. Multiplying it in here, the 3's are going to cancel, and we get minus 2 x 1/3. This now matches this numerator exactly. But what do we do with the fact that we've got 3/2 out front here on the left side? Well, all I need to do really is multiply it in on the f value. You can multiply in 3/2 on the g as well, but the only thing is we already have the g exactly the way we want it to match the formula. So what I want to do instead is let's multiply it in on the f. Multiplying in a constant and taking derivatives is not going to change anything, so I can just do it on both the f function and the derivative. So doing that, our new f value, multiplying this in here, is just going to be 3x 1/3. This stuff's going to cancel out here, and our new f prime is going to be just x minus 2/3. So redoing this right here, just to be sure, like as a double check, this is going to work, but let's just do the double check to show that it's really working here. So for our f prime g, we're going to have x minus 2/3 times g, which is 1 plus x. And And then we want minus f, which is 3x 1/3, times g prime, which is just 1. Multiply this out, x minus 2/3, multiplying into the 1. Here, this is going to be x 1/3 minus 3 x 1/3. Simplify this, x minus 2/3 minus 2x 1/3. This matches this now. So now just to finish it off, we just need to remember what we're doing. We've got the quotient rule here inside of an integral. This is in the same form inside of an integral, but we're taking the integral of a derivative, so our solution of this is just going to be what's inside, or f over g plus c. So putting this all together, we've got our g value, we've got our f value. So using this for my final solution, we have just 3x 1/3 over 1 plus x, add a plus c, and that's it. Okay, there you go. Good one today from MIT 2023. Thanks everyone for watching. Have a good day.